Okay, good morning, class.
Good morning, sir.
So, the first part of the lesson we looked at the conclusion of the functions, exercise 5.21. So now we're just looking at, we have a few minutes left, we're looking at the trigonometry, the sine, cos, and the area rule. So, at this point, we are told that the division of solving triangles, this is on page 320, 330. Okay, so we're reading from page 330. So we're told that in grade 10 you learned how to solve right angle triangles. We will revise this before proceeding to solution of triangles that are non-right angled. So at this point, all your trigonometry was done in right angle triangles only, not so. You will need to know the basic definition of the three trigonometric ratios in order to solve triangles. We know that sine cos tan is x over r, y over r, x over r, and y over x. Otherwise, we also remember it as SOHCAHTOA, not so. Okay. Or Oliver has a hat of apples in that order, provided that you have sine, cos, and tan in that. Okay. Then we know that in your Cartesian plane, if you draw with your arm there, if you conclude this here, that would be your, this would be your x here, and that would be your y, of course. And if this is your angle in your standard position, that is your opposite, adjacent, and your hypotenuse there. Okay. Note, in any triangle, the side opposite angle A, can you see angle A? The side opposite angle A is written with a small a or lowercase a. Can you see that, people? This is capital C and this lowercase c, and capital B is lowercase b. Can you see that, people? That's the relationship that exists between triangles. Okay. With regards to the angles and the sides. To solve triangles, we need to calculate the length of all the sides. If it says to solve the triangle, that means you say you're going to calculate all the sides that is unmarked or unknown sides, or you can calculate all the unknown angles. Again, so to tell us to solve the triangle, we must calculate everything that is not given to us in the triangle. Okay. And remember that there are three angles in each triangle, and there are three sides, of course, in each triangle as well. In order to determine any unknown of any triangle, we need to know at least three elements of the triangle, one of which must be a side. Okay. People, this is example 1 on page. Example 1, page 331. Alright. So this is fairly simple. We have to write all answers correctly to decimal places when necessary. Okay. So as needed, we will write down our answers to two decimal places. The question says, solve triangle ABC. So how do I start this off? I draw the triangle ABC with angle AB 90. So am I going to put A here? No. We'll put A here, not so. Huh? Put A here? No. Put A here, not so. So then we are told that angle B is 25 degrees. So I'll just put angle B here. I could have put angle B there, doesn't matter. And then if this is triangle AB, then this has to be a C. Can you see that, people? We are told that AB is going to be 5 centimeters. Okay. So the question is solve triangle ABC. What does that mean? I must calculate all the unknown angles and all the unknown sides. We can start with the angle. How are you going to calculate angle C? Sum of triangles is 180 minus 25 minus 90. Work that out. Sorry? 65 degrees. Okay. What are you going to calculate now? You calculate AC. So how are you going to calculate AC? What is this? My opposite, not so. And what do I have? The adjacent side. So it's going to be, which trigonometric function is that? 10. So tan of theta, which is 25 degrees, equals opposite, which is AC over 5 degrees. Not so? So cross multiply. So AC is going to be 5 tan, 25 degrees. So let me calculate that. 5, 10, 25. Will give you 2,33. 2,33 centimeters. So how can you calculate CB? Pythagoras, or I could have used sine or cos. Not so. Let's use the Pythagorean theorem. BC squared is equal to 5 squared plus 2,33 squared. That gives us the answer. It's the last answer calculated on the calculator. So it's answer squared plus 5 squared. 30,343. The square root thereof. It's going to give you 5,52. So BC 5,52. You all okay with that? Any confusion? No? Look at example 2 quickly. We are told that example 2. We are told that intra-angle PQR. The angle Q is 90. Angle P is 34 degrees. PR, so that is triangle PRQ, then R has to line. PR is 14 centimeters. So what can be calculated here? Angle R. Angle R is equal to 180 minus 34 minus 90, which is 60 is 50, 6 degrees. Check. Somebody need to check, nah, if you are on the right track. Is that correct? Huh? No. But remember, oh, we only calculating QR. Okay. You are right. I thought they wanted to solve the triangle. So that is not needed. So QR, what is QR? Right? Opposite. Which trigonometric function is that? Opposite, and we have the hypotenuse. So it's going to be sine. So sine of 34 degrees is equal to RQ over 14. Cross multiply. So RQ is equal to 14 sine 34 degrees. Sorry? 7,83. See. Okay, you guys understand? Look at example 3. So that's example 3 on page 330. Good. Okay. So in triangle LMN. So this triangle LMN, angle L is 90 degrees. Then we are told that in L it's going to be 8 centimeters. MN it's going to be 12 centimeters. They wanted to calculate angle N. Sorry? MN. It's 12 centimeters. So what is this to the angle is your hypotenuse and this here? So which trigonometric function is that? Cos. So we say cos angle in equals adjacent, which is 8 over copies, which is 12. So how do I get 18 on this out? R cos. Not so. So R cos of 8 over 12 gives us 48 comma 1. No. 48 comma degrees. Okay. Any confusion there, people? No. Yeah, no, that is normal. People, for homework is exercise 10.1. I want you guys to do all the odd numbers. Okay, exercise 10.1 on page 332. Enjoy this every day, people. Good morning, class.
Good morning, sir.
Bye. Hi there, how are you doing? Good, good. Where were you on Thursday? Wanda? Hi there. Where were you on Thursday?
I was absent, sir.
Why you stay so much absent?
Hi, sir.
Hi there, how's it?
Hi. And yourself?
Good, good.
Can I must have work, sir?
Sorry?
I must have much of work.
Yes, you must working on your own now, isn't it? Okay. Did I go to the drawer change for you? And you as well? You mustn't stay absent now, Michael. It's almost prelim. Not so?
Yes, sir.
Alright. So you're gonna be serious now about your work.
Yes, sir.
How was the matric ball?
It was stressful playing, but it was actually nice, sir.
Was it nice?
Yes, sir.
What you expected or better?
I expected.
Better.
No, we actually got better than what we
You
expected.
expected. Nice. I'm glad. Vision, you got your change? Hi there.
Two, sir.